In this work, we tackle the problem of coordinating a team of robots in a perimeter defense task. The optimal team strategy involves solutions to problems such as coordination, task allocation, and routing. Formally, we have a perimeter represented as a unit circle, a team of n defenders constrained to move at the boundary of the perimeter with limited angular velocity, and intruder agents that move radially towards the center of the perimeter with constant speed. Our goal is to maximize the number of intruders that are intercepted before breaching the perimeter. As part of the coordination strategy, we estimate a probability density for the arrival direction of new intruders. This information is integrated into an adaptive partitioning step. Next, we have a partition-based coverage control. The previously defined density function is used as input and promotes a region partitioning. Each defender is responsible for capturing intruders that are within its assigned sector. A set of virtual agents is used to calculate the sectors, while the defenders might be moving inside it to capture intruders. Finally, each defender determines a collection of valid intruders, that is, intruders that belong to its sector and that are reachable. Reachable intruders are the ones that can be captured before entering the perimeter. This information is used to build a graph, and a path with maximum cardinality is selected. In this experiment, we show that the proposed approach is especially useful in situations with non-uniform arrival probabilities. Furthermore, the overall strategy can easily adapt to different scenarios and even time-varied distributions.